Hi guys, welcome to Learn and Build. And today we're gonna discuss about another topic, and that is union. So in last class we have discussed about structure. So in this lecture itself, we'll see what are the importance of union and why do we need it, and how it is different from structure, and what are the major differences that we have in between both of them. So this lecture will clear your mind with respect to memory allocation. So how does this variable, how the other kind of maybe data types used to specify the memory basically in C programming. So let us start discussing about the topic, right? So today, like in last class or till last class in C programming, we have discussed about structure part, right? The structure part. So all these things which we have already discussed, today we're going to discuss about union, right? Okay. So first of all, let us understand what is union. So as its name suggests, right, so it works with the kind of memory space where we want less amount of memory to be used with respect to variables, right? So like let me tell you, so we were specifying structure like this. So we had structure of record, if you remember in the last class, right? And we were talking about two things. One was related to the name, where we had suppose 30, maybe 30, 50, whatever the limit is, and then int marks, right? So this was the part of structure where, if you'll see, if this int will take 2 byte of space, or maybe if the compiler is of 32 bit, then it will take 4 bytes, right? If this character will take 1 byte each, then 30 byte of space will be utilized or will be used by this particular data type, right? So overall this structure is required 34 bytes of space, right? So it requires 34 bytes of space for any memory to be occupied. Okay, so where these 30 will be for character and this will be for int, right? 4 bytes. But can we reduce the amount of space so that only 30 bytes of space could be utilized, right? So so that see memory part, or the handling of memory part is quite good with this union, right? And you can say we can call it as set also, right? It can be called as set also. So how it is actually helping us to organizing our space, or maybe optimizing our space, right? So it is just like structure. So we have union keyword that we can use to define the unions also, right? So we are doing the same thing. We are going for the record, character, name. Again we have 30 bytes of space requirement here, and then we got marks, right? So what will happen here, it will be for 4 bytes and it will be for 30 bytes. But what happens in union, it just take maximum amount of information that we have stored somewhere in the data type. Suppose this variable is taking 30 bytes of space, so same space would be utilized for marks also, for name also. For if we could have 10 number of other data types, so all these data types will also be stored, or will store the value in the same space that name is specifying the data. So what happens here, once the amount of memory will be specified, so there are 30 bytes suppose. So how will decide whether how many number of bytes will be there? So larger amount of larger amount of space requirement with any particular variable, sort of variable inside this union would be there if here in this case we have name as it requires 30 bytes of space, and in other variables suppose only 4 bytes or 8 bytes or 12 bytes or 10 bytes. So then 30 bytes of space will be occupied first of all, right, from the memory, and this the same space will be utilized for all the data types. However, in a structure, what was happening, the amount of space that was occupied was like in this manner, right? So first of all character was declared, and then int was declared. If we could have some more variables, then these things will be coming in the same queue. But what happens in union, the amount of space that will be utilized only 30 bytes. If you would reduce this size to 20 bytes, and still this is the larger amount of space that we are required in any particular variable in union, then only 20 bytes of space will be occupied. Understood? So this is the beauty of union, and that is also a part of problem with the union. So we need to remember so how to work with this thing particularly, right? So let us understand the points, more points, basically I would say more points inside this union, right? Let us change the color. Yeah. So what happens in union, wait, yeah, what happens in union, so maximum amount of space will be occupied based on the amount of space that we are required for larger amount of variable, right? Yeah. So in our case that is name. So what will happen, suppose my name is Saurav. So Saurav will be occupied like this, right? Saurav, right? So suppose it took 0, 1, 2, 3, 4, 5, 6, overall 7 locations. However, we have multiple more locations also in the same array. So overall 30 locations here, 30 bytes of space is occupied. However, in remaining spaces, nothing is there, right? Those are blank. But still, we have stored a data of 7 bytes, right? So what will happen if after this name, marks will be stored. So first of all, in union, the remaining space will be deleted, and automatically at the same space your data will be stored for marks. So your marks are suppose 34. So 34 is there. So 34 will be stored like this. It's not the right thing to say like this. However, there will be 4 bytes suppose. So in these 4 bytes, 34, this data will be stored. Okay, right? These are 4 bytes. So what will happen in this case? The data which was available earlier of this variable called name, this will be deleted, and you would get only marks over here. So you have to utilize the same space, same amount of space. You can consider like you have a room, right? Either you can use this room as your kitchen, or maybe living room, maybe uh, for your maybe for your special room, maybe for study room, I could say, right? And those could be storeroom, right? So you can utilize the same amount of space for multiple reasons, but you have to look out in different ways. So this is a room, right? This is your room. If you are talking about union, then same amount of space could be utilized either for kitchen, living room, or maybe study room or store room at a time once for one particular thing. But what happens in structure, if this is a room, right, then it, the structure tells you that just specify a specific area for kitchen, this is for living, this is for study, and this is for store, right? So structure is something that will actually increase your space, right? Yeah. So now if your space, right? Because you have a limited amount of space here in union, suppose of 30 bytes. Then you have to utilize this space very very carefully, right? How? Because if you have stored Saurav here, right, and now you want to store a particular data, suppose 120, this is your data, right? This is your numeric data. Then you have to delete this Saurav. So if you would access Saurav later on, you cannot access this, because now, because 120 value, this value is stored. And after 120, if again you are storing like another thing, suppose L and B, right, learn and build, you are storing, suppose, maybe another thing called Jaipur, right? So again and again, whatever you are going to store will actually delete, will actually free up the space whatever was available earlier. And this is what is the beauty of union. So there are some problems and there are some advantages working with unions. Okay, so let us understand these things practically. So union generally to be used for optimizing our space. Okay, but while we are optimizing the space, we need to be very careful while working and using union, because your amount of space that you have is fixed for one specific thing, right? You have fixed for suppose name 30 bytes are bytes are going to be used. Then any other data will actually actually erase the data which is available in other variable, and will store the second amount of data, right? So the first very good thing with union is optimizing space. You can call one variable at a time, time, right? Third is third and very important, and I would say these are the major differences that we have in between structure versus union, right? Structure versus union. And the third part is that you have that you have one specific variable, right? And with that DMA you can at least control the space requirement also. So here in union, what will happen, that if you have specified the larger amount of space that you are required is 100, so this 100 can also be changed for 70, maybe for lesser than the requirement, or maybe greater than the requirement, 150 maybe, right? But in structure, so we need to take care of space for every single variable, right? We need to take care of every single variable. Suppose we have name, we had marks, we could have roll number or something like this, right? So for every single variable we need to take care of the space requirement in case of dynamic memory allocation. Okay, so these are the these are the important section that we are there that we have there in this union basically. So now let's try to look for the implementation part of this particular union, right? And we'll also see the part that I'm telling you for the space requirement, what is that. Okay, okay, so one important thing is, let me, yeah, so this is what we have there to check. So this is what we have, editor. Yeah, so let me remove this structure part first. Yeah, so let me remove the structure part also. We don't need a structure. Yeah, so here we have declared union, and we have declared a particular element for union, that is S. So we are trying to check what will be the size of S, right? So it will take 4 byte, it will take 4 byte. So overall, if it's a part of structure, then it will take 8 bytes of space. But because we are working with union, so only 4 bytes of space will be there, right? Only 4 bytes of space will be there. And then we are asking about to enter the ID from a user, and we are printing it out, and then we are asking them to print your marks, and then again we are printing it out. Okay, so how much percentage of marks that you have entered. Cool. So how to connect your element with the data type that you have declared in this particular union, similar to structure with dot, right? This dot is going to help you for connecting these things. Okay, so let me run this code now. Now I have to check or select the language. Yeah, so size of union is 4. However, overall space that we have got here is 8 bytes. Okay, so enter your ID. Suppose my ID is 100, and enter your marks. We have got, suppose, uh, 20 marks, right? So my marks are 20%, right? This is how we have printed these values, right, for both the variables. Cool. Okay, instead of ID, we can check it for character, and that is for 30, suppose, right? Instead of D, we can check it for S. S for ID. Instead of ID, it will be, sorry, let me change this, char name, right? Instead of S dot name would be there, and similarly instead of ID, it will be name, and this will be S. Cool. And this is more convenient method to check whether what will be the space. Now maximum amount of space for this union would be 30 bytes. Okay, let us run this. Something the size of the, okay, what happened is maybe comma or something. Yeah, here there should be a bracket. Let us run this code now. Yeah, size of union is 32 bytes. 32 bytes. Okay, so the first character, it will take 2 bytes, and there'll be 30 amount 30 bytes of space that will be required for array, right? Yeah, so enter your ID. That will be, suppose, 100. Okay, so it's not an ID, it's a name, right? So let me put it there, Saurav. Okay, my ID is Saurav. Okay, marks are, suppose, 55%. So my marks are 55%. So this is how you can use union. Okay, let me change this ID to name, and similarly this thing to be changed with name. Okay, let me run it once again. So amount of space is still 32. Enter your name. Name is Saurav, and ID or marks are, suppose, 79%. Right? So marks are 79%. This is how you can enter your data, and this is how you can connect this variable also. Okay, if I'll change this space to 50, right? Let me run this once again. Now it's coming 52, right? It's coming 52, and that we have checked the reason also. Now enter your name. Suppose I am entering Saurav Bharadwaj, right? And my marks are something that we have crossed the limit, maybe somewhere, right? That space or something maybe. So let us put it once more. Hi, hello. Yeah, so again this space is creating a problem. Let me put it once more. Hello, hello. So it's, enter your marks, maybe 67%. Yeah, so it's coming up quite correctly. What we have to check it out now. Let us check whether if we declare now this record with struct, right, as an structure, so the amount of space that will be required for this entire structure will be different from the union, right? So let us put struct record, maybe record 1. Let us put different name here, record 1 as s1. Cool. Yeah, so let us try to print this amount of space. is required for a structure is S1, right? Size of structure is size of S1 that we have declared the element for record 1, and record 1 is structure, right? Yeah. So run, what happened? Something missing. Oh no, let me check it out. Percent %s. What happened? Here record one, and what else? Do we need to change something else? Maybe suppose we want to change this marks name 1, marks 1, and something semicolon, maybe, I don't know. Let us check it out. It marks 1, record 1. Cleared everything. Size of union is percentile D. Yeah, the spelling. The spelling is for structure. Cool. So size of union is 52. However, size of structure is 56, because here we have added, or this structure is adding 4 more bytes for this particular int, right? 4 bytes for this int. So overall space requirement for this particular structure would be 56, right? Bytes. So enter your name. I have entered SOR. Then marks are 87. Yeah. So what if we'll introduce one more variable, int a, yeah, int a, int a 1 maybe. So let's check whether what will be the space requirement now. Still for union would be 52. However, the space requirement has increased by 4 bytes per structure, right? This is how it will be. Marks are 29%. Yeah. Now if I'll increase it with one more character array, right? So that will be maybe roll number, and O is 1 is equal to, or maybe let us give the array for 10 bytes, right? Similarly, let us just copy and paste that thing here as well, and let me remove it here. Yeah. So for union it will be only 52, still it will be 52, but for record 1 for structure it will increase by 10 bytes. So an amount of space would be, because the space was required for structure was 60 bytes, right? Now 10 more bytes would be added, and 2 more for character, then overall 12 number of bytes would be increased, so it should be coming 72, right? Yeah, so it's 72. However, union is taking only 52 bytes of space. So third part that I was talking about here for dynamic memory location is going to help us. Let me put it more clearly here. Yeah, so this part, dynamic memory allocation, is going to help us for faster execution, FE, right? Faster execution of the program. Why? Because here in union, less amount of space is going to be utilized. However, in structure, more amount of space is going to be utilized, right? So union, I mean, working with union will be more faster in program compared to structures. But again, we have to take care of the space that we are utilizing in union, because once we have utilized some variable, and you're going to store some other data also, like I'll show you here also. What we are doing, we are just taking the input from a user and we're trying to display this here, right? If I'll just copy or cut it from here, wait, because program is running, so let me complete that. Marks are 78. So if I'll just cut it here from here and I'll put everything together. So what I did, I try to print name and marks together. And first of all, I'm taking input from user for name, and then I'm taking input from a user for marks, right? So both of them would be entered. If this could be structured, this could be a structured part, then name and marks would be printed here. But because we are working with union and the element that we are using here is s, so what will happen? So what will happen here, that your name would be entered, but at the same space it will enter your marks. So your previous data would be cleared, and only marks will be available. Then this mark, suppose I have entered 65, so 65 marks in string would be printing a, right? Capital A, because 65 will be treated as the sky value, right? And now you don't have mark, I mean name, data of a name that you have entered from a user side is not any is not available with the database or space anymore, right? In case of union, right? So let me show you once. If I'll enter the name was Saurav and marks are suppose 65. Yeah, so only A is coming up rather than complete Saurav, because your data is replaced by this particular int data, and that those are marks, right? So you need to be very careful while working with union, right? Wherever you have to use it, while working with calculation, suppose you are going for some calculation and you are taking some user input continuously, and later you want to just decide which formula you want to use in mathematics, right? So this kind of work literally be little complex while working with the union, because your input will be at one side, and then you'll be calculating some different calculation you'll be doing on those variables later on. So these things will be literally hard to work with the union part, okay, right? So this was the important section that we have discussed today for union. I hope you have understood this part, right? So uh, if you'll have some questions, try to prepare those questions, and we'll try to discuss those doubts, those questions in the doubt class, right? So that's it for today. We'll meet in the next video and we'll discuss about the next topic that we have for file inputs, right? This is called as file handling also. So how can you store data that you are working here in program in any particular specific file, maybe text file or something else, right? Similarly, if you have stored some data in a file, then how can you retrieve the data, right? So what are the operations and how to work with those variables, what those data that you have stored of different kind, maybe it could be text, character, or numeric data, anything like that, right? How can you work with those particular data, right, that you have stored in a file? It's called as file handling. And then we'll be working on dynamic memory location allocation, and with there we have got four important functions: calloc, or you can say them as calloc, right? Calloc, likewise malloc or malloc, likewise realloc, right? So it is called as allocation. It's called as allocation, and there is a function called free. So how can we use those four functions basically? And I'll tell you how to work with the DMA part, right, in next class, okay? So let's connect in the next class, and keep doing your practice. Try to figure out the doubts, and we'll discuss those things in the last doubt class. Cool. So thank you for attending the class. Bye bye.